Welcome back to the channel. We are now moving on to the section E, Analytics and Application, where we answer and explain some of the most important conceptual fill-in-the-blanks questions asked in data science, machine learning, NLP, and big data systems. These questions check your understanding of ML theory, dimensionality, NLP pipelines, PCA, Spark, Hadoop, and etc. So let's get started with the first one, which is no single ML algorithm performs best on all problems. Refers to dash algorithm. The answer is no free lunch. No free lunch. So the no free lunch algorithm states that there is no universally best machine learning algorithm, that an algorithm performing well on one type of problem may perform terribly on another. This is why we compare multiple models, we tune hyperparameters, we do not rely on one perfect algorithm. NFL theorem is one of the most fundamental principles of machine learning. Moving on to the second question, the method that uses smaller training data subsets repeatedly to estimate test error is called. So the answer is cross-validation. Sure. Okay, so cross-validation repeatedly splits the dataset into training subset and validation subset. The most common version is k-fold cross-validation, where the training happens on k-1 folds and evaluation happens on 1 fold. This method reduces overfitting, gives a more stable error estimate, and helps us choose the best model. Moving on to the next question, in KNN, runtime growth with O of n into dash, where n is the number of points and d is the dimensional. So the answer is D, O of n, d, it's a time complexity. KNN is a lazy learner, it does not train, but prediction is expensive. For each prediction, KNN computes the distance between query point and all the n existing points. Each distance computation takes d operations once per dimension, so total runtime is O of n cross d. Moving on to the next question, the curse of dimensionality affects algorithm that depends on dash matrix. So the answer is distance. As dimension increases, distance between points become less meaningful, all points become equally far apart, distance-based algorithm breakdown. The algorithm that are usually affected by these are KNN, K-means, DB-scan, clustering model, many similarity-based ML methods. This phenomenon is called curse of dimensionality. Now next question, PCA transform correlated feature into dash components, uncorrelated components. So PCA creates new features called principal components that are two linear combination of original features mutually uncorrelated ordered by amount of variance explained. PCA is widely used for dimensionality reduction, noise removal, visualization, and handling multicollinearity. So the next question, the process of mapping words to numerical vector in NLP is known as embedding. So word embedding converts words into dense numerical vectors that capture meaning. Examples include word-to-vec, GloV, fasttext, and transformer-based embeddings. These vectors help ML models understand relationships between words such as king minus man plus woman equals to queen. So yeah. Moving on to the next question, in a neural network, removing random neurons during training is called dropout. Dropout is a regularization technique. In each training iteration, a random subset of neuron is dropped, their weight sets temporarily become inactive. This prevents co-adaptation, overfitting, reliance on specific neurons. Dropout improves generalization, and it is used in almost all modern neural networks. So next question, Spark uses dash RDDs for fault tolerance distributed data storage. So the answer is resilient distributed data sets. Distributed data sets. RDDs are the fundamental building blocks of Apache Spark. They are immutable, distributed across cluster nodes, fault tolerance using lineage, efficient for parallel computation. RDDs also allow Spark to process massive data sets quickly and reliably. So next question, in Hadoop, YARN stands for yet another resource negotiator. YARN is Hadoop Cluster Resource Manager. It manages CPU, memory, scheduling of task, communication between nodes. It enables Hadoop to scale across thousands of machines. So hope you got a lot of important insights from this video, and hope to see you next time. Have a great day. Bye, and thanks for watching.